So what I have here is some equipment that I finally have to do some testing of some laser pointers that I've gotten for a variety of different quantum physics workshops over the past few years. Now, this particular set of laser pointers is very similar to the kind that you might buy on Amazon. If you just search for cat toy lasers and things like that, they're the sort of standard format laser. I've got them labeled by their color and what batch they came in to me. And by my name, I've got a green, a red, and a violet laser. And I've got some good batteries for them to do some testing. But the question always was, these are really, really bright. Well, okay, the red one's okay. The red one, maybe that's a little brighter than what you might normally have for a pointer. For the violet one, it's dim because our eyes can't see violet very well. You can see it really nicely on the video. But then there's the green one, and I don't have batteries in it right now. I'm going to show you in just a minute why I'm pretty careful with the green ones. So the thing that I've got that lets me do a little bit of experimenting here is something that I got from eBay. HWLPM Mini 10 Watt Portable Laser Power Meter. I cannot read Chinese text here. I presume it says about the same thing. According to this, and we'll see if this is true in just a moment, or at least if it's within the capability to measure all of these. Supposedly 200 nanometers to 10,600 nanometers. This should be able to give us the laser power for anything in the visible spectrum and well beyond into the ultraviolet and up into not just near infrared, but pretty far into the infrared. Measuring range 0 to 10 watts. It is the display I'll show you in just a minute is just a 7-segment, I think 4 or 5 digit display. Which gives us down to the milliwatt, so it's okay for measuring things that are, if you want to just know if it's 1 or 2 or 4 or 5 or 50. Destructive threshold, if you want to know how much it takes to just kill this thing, 100 kilowatts per, I'm not sure what that unit's supposed to be, but I don't think I'm going to be testing 100,000 watt lasers anytime soon. Response time 1, I think that probably means 1.5 seconds, but maybe 1 to 5 seconds. Measuring accuracy within plus or minus 2%. Actually, the people that I've seen on YouTube who've tested it against some more expensive meters have said that's not too bad. Resolution 1 milliwatt built-in power supply. Yes, I did charge it. This is not an unboxing video. I did charge it already to make sure it was ready to go. Standby time greater than 6 hours. Overall dimensions, blah, 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 70 grams. It's a small unit. And I actually really like the construction. This is a metal case, or at least appears to be metal. It has the 5-digit 7-segment display. It has a sensor port here, currently covered by tape. I'm going to try to keep that tape on there or use something else to cover it to protect it in the future. And then, interestingly, a mechanical latching switch. You don't see that very often. A lot of times our electronics these days have momentary push-button switches that then all the switching is done in the computer, but nope, this is a mechanical switch, and I kind of like that. So here's the basic idea. I'll turn it on. We see that on the display we've got 0.000, no current input power. If I open up, and the button has a nice little I'm on illumination. If I open up the port, we don't see any significant amount of reading with just ambient room light. So let's try the red laser. Again, the red laser is just a regular old pointer. Supposedly eye safe, which means less than 5 milliwatts. So the instructions say to turn on the laser, and I'm going to put it close but not touching. I don't want to touch the sensor, that would be kind of bad. I don't want to damage it. Turn on the laser, and then wait. I have noticed that the initial use sometimes takes several seconds, a few seconds, but it will eventually start showing us a result. At least it did in the past. Let's see if it does now. .002. Pointing right in there. .000. Just make sure that I. So holding it steady, we see it climbing to .004, so 4 milliwatts, 5 milliwatts, 6 milliwatts, and as I tested it earlier, it held at 6 milliwatts. So if you don't know about the regulations on laser pointers and lasers, anything that is less than 5 milliwatts can be labeled as, I want to say it's Class IIIb, which means probably eye-safe. There's different people have different opinions on that, but you definitely shouldn't stare into the laser, but the assumption is that Class IIIb less than 5 milliwatts of this type, probably accidental exposure is not going to instantly blind you. And you've only got 2 eyes, so, you know, that's kind of important. So 0.6 milliwatts, or 6 milliwatts, 0.006 watts. This is not, this doesn't qualify for Class IIIb. It's not an eye-safe laser to use for pointing. Now, these are supposed to be things that we would use with students in the classroom. This worries me, all right? So if the red laser is already above the threshold, what are the other ones? So let's try this violet laser. Now, this is one where I'm not sure if the specs for the laser power meter are correct, because when I tried this earlier, I did not get a result. So I'm going to go ahead and fire this. I'll hold it steady there. We'll give it about 20 seconds just to make sure. And no reading. We can tell there's a laser beam. One thing that you might be able to see here is maybe, it's kind of dark. Perhaps I can use a darker surface and you can see it. No, it's still pretty dark. Well, what you can't see on the video is there are some definite defects. This was not a high-quality laser diode. It looks almost like a, but under different circumstances I might call a TEM00, like there's 2 bright spots in there with a dark dimmer spot in the middle. So maybe this is a faulty laser diode, but also it's possible this is a violet laser diode, 405 nanometers I think is the wavelength. Can't read it on there right now, but yeah, I think it's 405 nanometers. This may not be able to handle violet. I do have an ultraviolet flashlight here, 390 or something. Let's see if it gives us any result. No. It is showing some result. So this thing can see into the ultraviolet, which makes me think maybe that laser is just broken to the point where it doesn't have enough output. So the last one to check is the green one. I have some other violet lasers that I'll test with this laser and this later and see if it works. So the green one's the one that worries me. I'm going to close my eyes and just hit the button because you'll see how bright this is. Alright, it's not like burning my hand bright, but it's bright. Bright enough that it immediately tripped my senses going, this is not an eye-safe laser. So let's go ahead and take a little bit, I wanted some data to show exactly how powerful this laser is. Now, green lasers like this are known as diode pump solid-state lasers. They use a infrared pump laser, which usually is in the, anywhere from 100 to a few hundred milliwatts, which then fires into a secondary laser. Let's see. You got the initial laser, you get the wavelength shifter, and then, you get the initial laser, you get a secondary infrared laser, and then that is frequency doubled to get you down to 532. So high quality green lasers will have a good filter that filters out all of that infrared. Cheap green lasers, not always. They've gotten better over time, like more of them have it now, but some of them can leak a lot of that infrared, which you can't see, which makes it a class 4 laser and very dangerous. So let's just see basic how much power is coming out of this green laser. All right, we're at 50 milliwatts. I'm averting my eyes so that I am looking from the side so I'm not seeing any reflection or anything from the green laser. 80, 81, 82. All right, 85, 84, so it started to drop power. These lasers also suffer from essentially thermal limits, and they'll begin to reduce power if they start to heat up, which this one probably has. We saw a maximum of 86 milliwatts. Remember, safe limit is 5. This green laser I would never ever use in class, not even myself, without students being trained in laser safety and wearing laser safety goggles that are good for this particular wavelength. Unfortunately, that means this kit, the violet laser is a maybe, the red laser is slightly over, and the green laser is so far over that I could not recommend using it with students at all in a high school or basic undergraduate laboratory setting. So as for the little device, let's take a look at, I just wanted to show you the eBay listing. This is our eBay listing for the portable mini laser power meter pocket size measuring wavelength 390 nanometer. Oh, so here they say 390 to 1024 nanometers. So they've got a lower limit on both ends for the sensitivity on this laser. Currently listing $122. That is pretty expensive, but if you're trying to verify the safety of a laser, maybe it's a good first step to looking at whether that laser is appropriate for use in a laboratory or classroom environment. If you've got any questions, let me know in the comments, or send me an email, find me on Twitter, etc., etc. Otherwise, I'll be back at some point with some other investigations into the various other lasers that I've got, just to see, to get some data. How powerful are these things?